This is Chapter 5 from AS Applied Maths Statistics. We're looking at an introduction to probability. So in probability, we are predicting the chance that something happens. You should know this already from GCSE, and everything that we'll look at in this part of the course should be revision rather than new to you. So we're looking at a random experiment, repeatable process that gives a number of different outcomes. For example, tossing a coin, throwing an ordinary dice. What I want to focus on here is this idea of a sample space. So you should have come across sample spaces before, in particular sample space diagrams. This is just a way of writing down all the possible outcomes that we could get from the repeater process that we're doing in the random experiment. We generally list our outcomes between brackets, and we use the curly brackets when we're representing set notation, and that's not just probability, that is in all of mathematics if we were looking into number theory. But today obviously we're looking at sample spaces and listing all the possibilities, so I'm going to use the curly brackets. We might need to draw a sample space diagram. Now a lot of students avoid drawing these just because I think they see it as effort. But actually, once you've got the diagram drawn, or once you've written your sample space out and all the possibilities, it makes probability so much easier. So if I want to write down the sample space for tossing a coin, I have two possibilities: heads or tails. And I use the curly brackets to denote the end of the set. You can write it the full words if you want to. So you should be able to do 5.1.2 without me going through it. Sample space for throwing an ordinary die. So we've got 1, 2, 3, 4, 5, 6. Moving on. Example 5.1.3. So draw a sample space diagram for the product of two scores when two die are rolled. So the product, that means multiply. So the best way to do this is to draw a table that would look something like this, and we're just going to fill that in, and it's just a basic multiplication table. If this top was the first die, the side was the second die, so the possibilities are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, getting a 1 on the second die, and then these numbers on the first. What is really important to understanding probability is getting a 1, 2 or a 2, 1 are two different events, because we have two possibilities of that happening, and therefore there is a higher probability of getting a 2 on one die and a 1 on the other than there is of getting a 1 or getting the same number. There's only one probability of getting 1 on both of them. So you should be able to fill the table in. It should look something like that, and you can see the chance of getting a 2 as the score is higher than the probability of getting a 1, and that's because we can get that in two possible ways, and there are others where we've more chance of getting that outcome just by looking. So 12 is there, there and there. So if we're asked for a total, then we can work that out. We know we have 36 possibilities, so if I was to list it into pairs, so 1, 1, 1, 2, 1, 3, etc., there will be 36 different possibilities, but the sample space diagram shows that really easily, and then we should be able to go through now and work out these probabilities. So the probability of getting exactly 12, so just working through the table, once I've worked out my grid, probability of getting 12, I know that I've covered all possibilities there, so exactly 12 would be 4 out of a total of 36, and then we can simplify that down. If we were looking at less than 6, so the probability of getting less than 6, we are going to ignore that 6 there, but we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then checking everywhere else, so the 6, we've covered it. So I've got 10 out of 36. So we just put in the number that we've got in total on the numerator, and then the total possibilities, the total number of outcomes on the denominator, and then we can simplify that down to 5 over 18. It is worth showing your fraction before you simplify it down, just to make sure you don't make a mistake with that simplification. I mean, you shouldn't do, but then we all do slip up from time to time, so it is worth writing that down. An event. So terminology, an event is a collection of one or more outcomes. In set theory terminology, an event is a subset of the sample space. Sample space represents everything. An event is something that can happen. So going back to the last slide, when we had the event was getting exactly 12 or getting a number that was less than 6. The sample space was the whole thing. So, for example, when a dice is thrown, possible events are that the score obtained is an even number, that the score obtained is a multiple of 3, etc. An event will always be denoted by a capital letter. So that's just the way that probability is written down. So first thing that we're asked to do is we've got 3 coins that are being tossed right down the sample space. So just take a moment, pause the video, write down the sample space. You should then be able to finish this question and then just check in. So writing down the sample space, it's a good idea to do it with some structure so that you don't miss something out. So I've got 3 heads. That's getting 2 heads. Notice how I've got 3 different ways of getting 2 heads, and that's important that you consider all 3 ways. There are more chances of getting 2 heads when I toss a coin 3 times. That's getting 2 tails, and then I have got 3 tails. And then I can look at the events A, B, C. So this is the whole of the sample space, which I will put into curly brackets and write it out as a list. I've structured it like that just to help me kind of see the order of everything and make sure I don't miss anything. So looking for patterns is really useful. And then I can write the subsets here. So exactly 2 heads would be tossed is going to be that second line that I've got. So we've got those options there, and that would be event A. Event B, if we were looking at event B, we've got the third toss will give a head. So I can see that that would happen in the first situation that I have. So 3 heads. Then I've got tail. These 2 would have heads. And then on this third row, it's just the first outcome. And then the last triple T doesn't have any heads on there. So then looking that all 3 tosses will have the same outcome. So that's the first one and the last one. So they are the subsets. That's what I mean by a subset of the total sample space. So find the probability of A. So probability of A was exactly 2 heads would be tossed, and I know because I've taken the time to write this, I've got a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes here, and then I have got 3 there, so there's 3 out of 8. Probability of C, so that all 3 will be the same, that's 2 out of 8, also known as a quarter. Probability of A and C. So when we look at A and C, so exactly 2 heads will be tossed. So exactly 2 heads will be tossed, and that all 3 tosses will have the same outcome. Well, I can't have that situation, and the word and suggests that they have to happen at the same time. So I have to be able to get them. So it would be the overlap between the 2 groups, and there isn't any. So the answer to that probability is 0. If we want to look at the empty set, so if I'm talking about the empty set, you will come across the notation either like that, or you can use brackets with nothing written inside. Okay, so that was C. And then D, probability of B dash. That means not B. Okay, so the probability that B doesn't happen. Now the easiest way to work this out is to do 1 take away the probability that B does happen, because I've got B there. I know that that is 1, 2, 3, 4 out of 8. So the answer to that is going to be a half.